of authentic battle damage. And today we're going to continue to talk about rock, paper, scissors, and I'm going to show you what enumerations are all about. So here is our rock, paper, scissors. You can see we've got some functions in here now, methods. We've got our main function, our entry point for our program. And now we're going to create something that's called enumerations. Okay, we're going to create our enumeration at the class level. And the way you do that is you type enum and you give it a name. And what we're going to replace is right here, our draw, lose, and win. We're going to call it win state. And then we're going to create a lose. And we're going to say that's going to equal -1. Draw is going to equal 0. And win is going to equal 1. So now what this will do for us is we can go ahead and get rid of this. This should create a whole bunch of these for us, a bunch of red places that they're used. So now we can do this. We'll type win state.draw. And let me just copy this since we gave them all the same name. There we go. Okay, let's see why. Oh, I see the problem. Let's do this. Let's make them lose like that, draw like that, and win. Whenever it's good practice to label anything that's sort of a constant in all uppercase, so that helps. There we go. All right, great. Now we just need to replace these down here. So we got win state dot draw, win state dot lose, and win state dot win. Okay, there, perfect. So that's pretty simple. Now, what this helps with is readability. We don't have to deal with numbers. I mean, that's kind of why we created these in the first place, right? We created variables to represent the numbers, which is great. So now let's look for other places where we can use this. For example, in our win table result, we can now replace this with a enumeration. Now, let me show you what happens when we don't do that. You see here, he says the operator cannot be applied to operands of type int and rock, paper, scissors dot win state. So what it's saying is that this is giving us an int, and this is an enumeration, and we're trying to compare them. So this is exactly why we're going to have this return a win state. And this win state is going to be either one of these three. So it encapsulates our win conditions perfectly. Now, oops, let's see what we got here. Cannot implicitly convert. Oh, not a problem. See here we got ints. Now we can change it to win state. Let's find out where else we get some errors. Let's go ahead and compile. There we go. So inconsistent. Oh, accessibility. Return type. Rock, paper, scissors, win state is less accessible than method, rock, paper, scissors, win table result. So this is public, but win state, as if you come up here, you'll see is there's nothing here. Now, so what this is dealing with is access modifiers. So let's talk about access modifiers. In a class, you can if you don't put an access modifier, which there's public, private, protected, and internal. those are the different access modifiers that you can put. And public basically means that anybody can call it. Private just means that only the class itself can call it. In fact, we don't even need to make these public. We could make these private if we wanted to. But now what this is complaining about is because this is a public method and this is not, this is actually defaults to, I believe, private, either private or eternal. So that's a problem. Now, if we make it private, let's see what error we get. Inconsistency, yep, it gives us the same thing. So now we can, if we make this private, let's see what happens. We compile it, you'll see now that it works. It works fine because this is private and this is private. Another thing we could have done is we could have just removed this altogether and had it default, and I believe that would have worked as well. But you know what? Let's just make everything public. Now let's compile it and see what error we get. Oh, we didn't get an error because this is public, this is private. So this has more access than this does. So that works fine. So access modifiers. Yeah, so let's say we had another class over here that we created and we wanted to access rock, paper, scissors. Everything that's public, we'd be able to access it by doing, rock, paper, scissors dot, well, yeah, this should work. Let me see here, because it's all these are public. So display. Oh, I'm probably thinking that's wrong. Okay, so yeah, all right. So now we've got our win table returning a win state, and we've got these guys working correctly. So that's basically what an enumeration is. It hides your implementation details here in numbers so that you can have things mean specific things. It works out fantastic. Player score. What else is there? There's player. Yeah, I just feel like there's something else that we can change. Is there? Player score. Get player choice. Yeah, right here. Because the choices that we're getting are rock, paper, or scissors. So we could create another enum that represents enum weapon. Rock equals 0, paper equals 1, and scissors equals 2. There. And then we can get rid of this. Okay, so to have these work out properly. Okay. All right. Now we have weapon. Now we can add weapon to here. So we want to return a weapon, and then this is going to be a weapon, and we need to box this as a weapon, and then we're going to take this this right here. We're going to move it up here. -1. Is that right? Nope. Minus. There. And then that'll be converted to a weapon, and then we can just return player choice. That's great. Then we need to go to get computer choice, and we'll make that a weapon. There. All right, let's compile this and see what errors we get. Cannot implicitly convert an int. No, you can't. So let's just box a weapon here. All right, and then we just need to make these guys weapons. There. Great. Now the win table, you'll see here it's coming in with an int, so it's saying the best overloaded method has some invalid arguments because these are weapons, and so we need to bring in weapons here. All right, awesome. Now, all we need to do here is, because we're using our win table, and this is a win state. So what we can do here is we can convert our weapons into win state. Because they follow the same format, that completely works. Oh, win table. Wait, what? Wait, whoa. Oh! Okay. All right, so we're getting, it says here we cannot convert weapon to int. So this is an index. So because it's an index, we need to convert it to an int. So perfect. All right, everything looks like it's working. Let's go ahead and play it. I'm going to do rock to draw. Fine. Paper. Oh, I lost. And scissors. I lost again. Yeah. All right, great. If you like this, please go ahead and hit the like button. And if you're not subscribed, please feel free to subscribe. We're going to be going over a lot more of these concepts with C# and how they apply to games. Right now we're working on rock, paper, scissors, and we have a whole bunch of other games that we're going to be making and using all of these same ideas in the C# programming language. Also programming concepts and principles I've been talking about, and how they apply to all of these games and where we use them. So thanks for watching.